Hello, welcome to this video lecture. I'm Dr. Melanie Jigarat, and let's talk about the mathematics in our world. So here are the learning outcomes: to identify patterns in nature and regularities in the world, articulate the importance of mathematics in one's life, argue about the nature of math, what it is, how it is expressed, represented, and used, and to express appreciation for mathematics as human endeavor. So let us think about this. Mathematics is a useful way to think about the nature and the world. Okay, first, to explain this further, patterns and numbers in the nature and the world. So we actually can see patterns and numbers in our world, particularly in nature. So here is an example pattern. So as we can see here, so for the arrangement, so this is 1, 2, 3. So we have here a pattern: 1, 3, and 1. So another pattern. And some of patterns, so we have figures of patterns shown in the slide. So we also have the symmetry and butterflies and tessellations or tiling. So this is the pineapple. So it's a pattern of shapes that fit perfectly together and no overlaps or no gaps. Wallpapers or symmetry. So for the honeybee, so it is repeated until it covers a plane. It is a pattern. So we also have the radial symmetry. It's a circular symmetry, fractal symmetry. It's composed of smaller copies of themselves. Biological patterns, so patterns of these animals. So this studying growth and developmentals. We have also the spirals. And then next, we can also see Fibonacci sequence in our surroundings. So what's this Fibonacci sequence, by the way? It is a series of numbers starting from 0, where every number is the sum of two numbers preceding it. So 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and so on. But sometimes you can find some reference materials that starts with number 1 as the first number. So this is named after the Italian mathematician Leonardo Fibonacci. So in 2002, it was introduced in the Western world in the book Liber Abaci. So to better explain where these numbers came from, so let us answer this question: how many pairs of rabbits will be born in a year, starting from a single pair, if each pair gives birth to a new pair, which becomes reproductive from the second month? So the solution to this problem is the famous Fibonacci sequence: 0, 1, 1, 2, 3, 5, 8, 13, and so on. So it's a sequence of numbers in which each number is the sum of the previous two. So to better visualize what we're talking about here, so we have here a figure that shows now. So for instance, this is the legend. So if it's blue, it is in fertile pair, and then fertile pair, it's in orange. And then if we have this line, it means that the pair becomes fertile. Broken line, it means that the pair survives. And this arrow, it means the pair generates another pair. So starting from 1, 0, so this is the infertile pair. And then it becomes fertile now, so it turns into orange. And this fertile pair survives, and the pair generates another pair. So this is the another pair. And then after that, so again, these two pairs survive. These two pairs, or rather, I mean, this pair becomes fertile, and then this the pairs now generates another pair. So here it is, the fertile pair is 0 in month 2. The fertile pair is 1 in month 3. The fertile pair is 1 in month 4. We have 2 fertile pairs. And then for month 5, it is 3. And then, of course, the process continues. So we have 0, 1, 1, 2, 3, which is the Fibonacci sequence. In mathematical formula, we can write the Fibonacci sequence, or rather Fibonacci number, as x sub n is equal to x sub n minus 1 plus x sub n minus 2. So that's actually the two previous numbers to get x sub n. So the phi of, or the golden ratio, this is golden ratio of any two consequent numbers of the sequence, is 1.618, and this is the golden ratio. It's also called the nature's code because it's observed in several natural phenomena. So this is the rule. So when we make a square, so this is the squares with one, so with 1 and 1, and then another square with 1 and 1. So it fits together. So this is 1, 1, and then this is the width is 2. The width of this square is 3. The width of this is 5. And the width of this is 8. So the Fibonacci sequence here is 1, 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 8 is equal to 13. So a larger square. So this is now our spiral. Okay, so where can we find the Fibonacci numbers? So we can find it in leaf arrangement, florets in the flower, bracts of pine cone, the scales of pineapple, hive of bees, a grain of wheat, and even in mankind. So this is an example. So we have here figures that shows the Fibonacci. Okay, now, how about for the golden ratio? As mentioned, if we're going to consider now the larger number over the lower number and the Fibonacci arrangement, so we will get 1.618, which is the golden ratio. This golden ratio is also found in arts. It's also called as golden mean, golden section, and it's symbolizes using the letter, or the symbol used is Greek letter P. So these are examples of arts. And some other things that we also need to consider by saying that mathematics is in our world is that mathematics help organize patterns and regularities in the world. So we also have here that mathematics help predicts the behavior of nature and phenomenon in the world. It helps control nature and occurrence in our world for our own ends. And it has numerous application in the world, making it indispensable.